probably, so this is the only thing in this is our last lesson in this unit, and I'm gonna break it into two parts. Y'all have seen this before, just a little bit differently than, like y'all wouldn't have known that it was called literal equations, you wouldn't have known it had a name. But all of this you've kind of seen because you've worked with formulas before. So if you notice over here, like this problem right here and this problem right here, they're really the same type of problem. This one is just numerical where I'm solving for a variable. Well, over here I could solve for a variable also, but there's more than one letter in the problem. The one y'all seen the most often would be like this right here, where they want you to find the height, and we would have to divide by b to get over to a. This is the one I talked to y'all about at the very beginning of the school year. Y equals mx plus b. Y'all would have seen that one a lot last year, where they gave it to you in a different form and you had to rearrange it and get it into slope-intercept form. This is the one you see the most this year. We see it frequently because they give you linear equations but not in slope-intercept form, and you can't graph them until you get them into slope-intercept form, so we have to do a lot of rearranging. And so this, right, doing literal equations, it's really important that you get comfortable with doing that because we see it so often. All right, so a literal equation has more than one variable, and it can be rearranged to solve for a specific variable. So if I went back up here, for example, to this y equals mx plus b, and I wanted you to solve it for b, then I would have to subtract the mx to the other side so that b would be by itself. Does that make sense? So they're going to tell you when you have problems like this, they're going to set it up, and then they're going to tell you which variable they want you to isolate and get by itself. Formulas are great examples of literal equations. That's what you're gonna have seen the most are these formulas. So this one right here, it says, what are 3 literal equations you have seen and used before? So which of these up here, like we know you've done y equals mx plus b, like I know you've done that one before. You should have also seen that area formula, A is equal to BH. You should have seen last year, A is equal to I R squared H. Y'all should have seen that one. You also would have seen C is equal to ID. And you should have seen A is equal to 2 I R H. So all of those are examples of literal equations. And frequently, they have asked you, last year, they would have asked you to find H, and you would have had to rearrange that and get H by itself. You just usually had numbers in the problem with it. This year, you're not always going to have numbers in the problem, and the whole problem is going to be letters. And we're just isolating, but we use the exact same process as we do for regular equations. So we look at this problem right here. What they're doing is we're going to do a numerical version, and then we're going to turn around and do an algebraic version. What we're going to do. So in this problem right here, if I wanted to get b by itself, what do I need to do? Divide both sides by 4. So I would have b is equal to 144 divided by 4 is 36. So I would get b is equal to 36. Okay, on this problem over here, it's a similar problem, but I have all letters. I want F. So how do I make E go away? Divide by E. So then I have F is equal to D over E. And I'm going to leave it like that. I'm not going to do anything else. I'm just going to leave it there. Is everybody okay? All right, this one. If I want to get X on the left side, what's my first step? Okay, subtract the 9. So now I have 13X is equal to 91. Now I'm going to do what? Divide both sides by 13, and x is equal to 7 there. Okay, so this one right here. So yeah, this is a formula you're used to. They just gave it to you a different way. They don't want y, they want m. So what do I have to do first? What's the first step? I'm gonna subtract b. Now, when I subtract b, can I really subtract b from y? Not technically, because I don't know what either of them are, right? So when we write this, I'm gonna put a minus b back here, like it's offset. It's not underneath the y. Does that make sense to y'all? Okay. So I have mx is equal to y minus b. That's something that looks like that. Everybody okay? Why it's written that way. Okay. Now I want m, so who's got to go away? X. How do I get rid of it? I'm going to divide it out on both sides. So I'm going to divide it here, and I'm going to divide it here. So it goes away here, so I'm going to have m is equal to y minus b over x. Now, this could also be written as, and I'm going to turn my paper sideways so I have a little bit more room. This could also be written as m is equal to y over x minus b over x. So that means the same thing because they have the same denominators. Everybody okay with that? Alright, so I just want to make sure that you're comfortable that it could be written either way. Probably for me, I would say leave it this way. It's a little bit easier, so I would leave it that way. Alright, this problem here, they want me to solve this for h. So I have 5 times 12 times h, right? So I can get rid of 5 and 12 at the same time. Are you okay? Because they're connected to h in the same way. So I can divide them both together. Are y'all alright that I can do that? Okay. So I can divide by 5 times 12. And I can divide by 5 times 12 over here, which is 60. So 360 divided by 60 is just what? No, divided. 360 divided by 60 is going to be. Because that's going to cancel and that's going to cancel, and I have h is equal to 6. Y'all okay there? So if you wanted to go ahead and multiply them together first, you can do that. That's totally fine. It doesn't make any difference. I wrote it that way because if you look at the next problem, we have the exact same situation. I want h, and I have a length and a width that both need to go away. So if I'm allowed to do it with the numbers, I'm also allowed to do it with the letters. Are y'all okay there? So I'm going to divide both sides by LW. And so they cancel on this side, and I have h is equal to b over L times W. All okay with that? Anybody have a question at all? Okay. This one here, I'm solving for n. So what do I need to get rid of first here, you think? I need to get rid of the 2 times 7. And so how do I get rid of the 2 times 7? Well, how are they attached to the end? They're added to the end. So if they're added to the end, how do I get rid of the addition? I have to subtract them to the other side. Does that make sense? Like, yes, they're multiplied together. So what I'm going to do is I'm going to write it like as, I'm going to still write it as minus 2 times 7 and minus 2 times 7 over here. But before I subtract that out, I'm gonna do 70 minus the 14. Are y'all okay there? Like I'm gonna multiply together in my head and just do 70 minus 14. So that gives me 56 is equal to 2 times n. Now, now I can just divide my 2 out. So I have n is equal to 28. Alright? So again, the reason that it's written that way, because it's not really the normal way we would write that, but they wrote it that way because I'm allowed to do it that way with the letters, and they want you to see how that happens. So in the next problem, I have the exact same situation. It's just that I don't have numbers here, I have letters. So MJ, yes, they're multiplied together, but they're attached to K by addition. Are y'all good there? Okay, so I need to subtract them. And I'm going to write it out here. I don't really love the way that is, but they don't give me enough room. So those go away. So I'm not going to write negative mg plus h. I'm going to write h minus mg. Are y'all okay there? Okay, so h minus, or sorry, mj is equal to 2. Okay, all right. Now I need to do what? Divide both sides by 2. So I have K is equal to H.
H minus MJ over.
There you go. H minus MJ over 2. And this one could also be written as like H over 2 minus MJ over 2. We could split that into two fractions. Are y'all okay that that's allowed? We're not normally going to do that, but we could do that. All right, here. What am I doing with next? All right, what do I do? Multiply by 2. So that goes away, and I have x is equal to 150. So here, all right, here we've got Q. I need to get Q, so what do I need to do? Multiply the R off. So it cancels on this side. So I have Q is equal to RT. And typically I'll write them alphabetical. I mean, TR is okay. I would just write RT because R comes first. All right. Here, this one's a little bit tricky. I need to move what here? 144. How do I move it? Subtract it from both sides. Okay, so I've got C squared is equal to 25. How do I get rid of the square? Take square root. So I'm going to take square root here, and I'm going to take square root here. And C is equal to technically both positive and negative 5. It could be either one, depending on the circumstance. If it's just straight math, it's plus or minus. If it's real world, it's most of the time only going to be a positive option. Everybody okay there? All right, so here, similar situation. I want x squared. What has to move? Or sorry, I want x. Sorry. What has to move? Y squared. So how do I move it? So I'm subtract it, and I'm going to write it back here because technically it can't go underneath the z. So that goes away, and I have x squared is equal to z squared minus y squared. Are we okay there? And I apologize that my z's and 2's look the same. They just do. All right, but I don't want x squared. I want x. So I need to, I'm taking the square to both sides. Now this one, be really careful here. So this is x is equal to, this all has to stay underneath the radical. You can't say the square root of z squared, like you can't take that and say z minus y. That is not a true statement. So that's a really special in this particular circumstance because that's a binomial. Those two things are attached. And so I can't just take the square root of this one and the square root of this one and put in subtraction in the middle. So that's as far as you can go with that. Are y'all okay there?